Okay, everybody. So I decided I need to make a video it's not really over any particular topic, but just a video with some assorted problems. Because I've already made videos about what the derivative is, what tangent lines are, and the concepts are out there. But I just need to have a few problems that were varied a little bit, okay? All right, so we got assorted problems here. Let's look at the first one. So say we have a curve here, and most of the problems that we do when we're learning this idea start with a curve, okay? Curve is y is equal to root x plus 1. And the question I want you to think about is, at what point on this curve is the tangent line parallel to this other line, okay? All right, so at this point, you should know the concepts. You know what the curve is, right? You could graph it on graph paper. There's points on it and so on. And you know what the tangent line is. And I want to find that somewhere on this curve, the tangent line runs parallel to that line right there. So let's look at this. Let's see. What is this? Let's think more about what this line is that's going to be our reference for being parallel. I don't really like the way that's given. I don't see the information that I want to see about it. So suppose that I solve it for y, okay? So I'll move the x over, and it looks like that. And this is a step in the right direction, but say I divide by 8 at this point. Y is equal to 1/8 x plus 4. Okay, so that's a little bit better for me, because I can see that this is a line that has a slope of 1/8 and has a y-intercept of 4. So I feel like I know a little bit more about it when I write it this way, okay? Now, you definitely don't, I don't know if I've said this before in the other videos, you don't have to draw the pictures to do this. It's really just math, it's equations, it's numbers, but I find that a lot of people are visual and they like to see what's happening. So I'm going to go ahead, I'm going to draw a picture along with my work, but I'm not saying that you have to do it that way, all right? Because you're learning, I'll show you like that. So what is this thing, okay? 1/8x plus 4. Well, so my graph is not to scale, all right? So there's my disclaimer, but it's good enough for teaching purposes, okay? So there's our line, okay? And I'll go ahead and I'll give it by this original equation. That's the line 8y minus x is equal to 32. Now, if you imagine the tangent line to this curve, somewhere on that curve, I'm going to get a tangent line that runs parallel to that one. Where is that point? That's what it's asking us. Now, I know it's out there. I mean, if my curve, even though my scale is not perfect, this looks about right. And I could put it maybe right there. Now, for my graph, I have no idea where that point is, but you got to be convinced from my picture that there's a spot on this curve that the tangent line at that spot runs parallel to this one. So where is it? All right. So let's translate this question a little bit. This question is like saying this. Where is the point on the curve such that y prime, the derivative that tells you the slope of the curve, or accordingly the slope of the tangent line at that point, I need that to be 1/8, because that's what it would mean to be parallel to this, okay? All right, so what's y prime? That's the next question. What is the derivative? If that's y, the curve, y prime, the derivative, is the slope of the curve, okay? And based on what we've learned, how do you figure that out? It's not easy, but this is what you do. And we will learn other things, and it might even be that you already know some shortcuts, some faster ways to do this, but this is what we learned so far, okay? That's how you'd find y prime. And I have a video devoted just on how you do this for different kind of problems, okay? All right, now for this video though, I want to focus more on solving this problem. And so I'm going to just tell you what y prime is going to be, okay? So if that's y, and you go through the limit process with the difference quotient to find y prime, this is what you're going to get. We get 1 over 2 root x plus 1, okay? And if we force that to be 1 over 8, we solve it for x. And what's x? X is going to be the x coordinate on the curve that makes y prime, the slope of the tangent line, what we want it to be. So if you just solve this for x, you'll find the point. All right, so if for me to solve this, I would cross multiply because I have one fraction on each side, and that's the technique for solving such an equation. So I'll get 8 times 1, so I get 8, and then I get 2 root x plus 1 times 1. Okay, and then I'll divide both sides by 2, so I'll get a 4 here, like that. And then I'll square both sides. So square the left, square the right, and then we'll get 16 is x plus 1. I square both sides because I need to eliminate this root in order to isolate the x. And then I'll get x is equal to 15. Okay? All right, now 15, that seems to be our answer. 15 is a number, and I'm looking for a point. All right? So 15 here says that if you can find the point on this graph that has an x coordinate 15, that's where you want it to be. All right? So let's say 15 would maybe be about right there. So 15 for x. And I want the point, so a point has an x and a y coordinate. What's the y coordinate? Well, that's the point on the curve. What do you do with this equation? You put the x in, you get the y out, that gives you a point on the curve. 15 is where we want to be. 15 plus 1 is 16, root 16 is 4. So there's this point, 15 for x, 4 for y. Okay? All right, that's the place that we want to be. And, you know, just for illustration purposes, if I took the tangent line at that point, that's what it would be right there. Okay? The tangent line matches the slope of the curve at the point where it's tangent, and see, it's parallel to that one. All right? So that's an illustration of the thought process and what we were trying to find. In the box there, that's the answer. The box, the question just said, what's the point? All right, I found the point. But if you want to see the whole picture, that's the whole picture. Okay? All right, so let's try another one like this, but go into a little bit more detail about it. So let's do this one here. Okay? All right. Sounds the same, but I'm asking for a little bit more detail in the answer. So you got the curve, y is x to the third power plus 1. And I'm looking for the equation of the tangent line to this curve that's parallel to that line. Okay, so that line 12x minus 4, that's a line that has a slope of 12. I know what I need to know about it already, okay? So if, you know, once again, for the sake of illustration, I could do something like this and say, all right, there's my reference line. See that line right there? That's y is equal to 12x minus 4. There is a place on this curve where if you extrapolated the tangent line from that spot, it'd be parallel to this. Where's the spot? And what is the equation of that line? Okay? Now, here, again, my graph is not to scale, but it's still realistic. It looks like that curve, okay, if you were to plot it. It looks like there's going to be two answers, okay? You know, I can, like, maybe a point over here somewhere and maybe a point over there somewhere that run parallel to this, okay? So first thing, I mean, I guess if we're doing some math, I mean, you can just, like, kind of push through the math and just do it and solve the equations and not think about it. But sometimes it's nice going into a problem to know what to expect. And I'd say, well, I think there's going to be two answers to this one. You know, it certainly appears like there could be two places on this curve where the tangent line would be parallel to that one. Like maybe one like roughly about there, and then another one over here, okay? 2 spots. So I'm expecting 2 answers. If I don't get 2 answers, I really think that something is wrong, okay? Because I can tell by looking that there's going to be 2 answers. Anyway, all right, so we'll translate the question again. The question there seems to be asking us, where are the places where y prime is 12, right? Y prime gives you the slope of the curve. The curve is y. Y prime tells you the slope of the curve at any point that you're interested in, okay? So where is y prime going to be 12? Okay, so once again, how do you find y prime? You find y prime as it's not the only way to do it, but this is what we've learned so far about finding y prime. There are shortcuts and other ways to do it, but everybody starts by learning this, okay? So yes, at some point we'll learn shortcuts, but everybody starts here. So, all right, so let's say that you do that. I don't want to make this the focus of the video. If you needed help working on doing that, you need a little more practice, you'd like to see a video with some more problems in it, then I can do that. But for now, I want to focus on this. For this curve, I'll just tell you, y prime is 3x squared. Okay? Y prime is 3x squared. Okay, so I'm amounts to solving 3x squared is equal to 12. All right, so to solve that, I'll divide by 3, and I'll get like so. And now it seems to be saying, what do you square to get 4? Well, you could square 2, you could square negative 2. So there's 2 numbers that do that. There are 2 answers. So I expected that. Now, whenever you solve for a square, like you solve x squared is equal to something, you solve that kind of an equation, then, hold on, gotta plug the charger in. Then you solve it by taking plus or minus root of the other side. So we're going to get x is equal to plus or minus root 4, or plus or minus 2. Okay? All right. So yes, there's 2 answers. Either way you look at it. 2 squared is 4, negative 2 squared also 4, but the technique is to take plus or minus root. Yeah, so look, 2 points, 2 answers. Okay? All right. So now, how about this? I got my picture up there, right? Let me resketch something right here, just for those of you that are visual learners. So I've got this curve like so, and I want to find a tangent line at the point where x is 2, and I want to find the tangent line at the point where x is negative 2. All right, so yes, remember, I said, I think that there's going to be a point here where the tangent line runs parallel to that one. And I think there's going to be one over here too somewhere. Okay? So yes, so let's do this. Let's say, well, there's this point where x is 2. What's the y coordinate of that point? Well, that'd be 9. Okay? So I'm looking for the tangent line to this curve at 2 for x, 9 for y. All right? And then there's a point over here somewhere. Okay? And it has an x coordinate of negative 2. So I'm looking for also the tangent line at the point negative 2 for x. What's the y coordinate? Negative 2 to the 3rd power is negative 8, plus 1 is negative 7. Okay? All right. So I'm looking for those, and I'll call this one tangent line T1, and I'll call this one tangent line T2, okay? They're parallel to each other, right? That was the intention of the problem. All right, we were finding 2 lines parallel to that one, 2 tangent lines on the curve parallel to that one. Here they are. Okay, so how about this? First we'll find, let's just do one at a time. Find tangent line T1, okay? All right, now, so what do I know about it? It is a line. Lines have the equation y equals mx plus b, okay? I know the slope of the line needs to be what? Well, the whole concept of the problem was that we were finding the tangent lines that have a slope of 12 in order to run parallel to this one. So it would be y is equal to 12x plus b, okay? So I know the slope. The other parameter in the equation is the y-intercept. What's the y-intercept? Well, for line T1, I have no clue where that hits the y-axis. I can't tell from my picture, but I know that it has this point on it, okay? It hits that point. It goes through that point. It's tangent to this curve at that point. That means this point is on the tangent line T1, just like I drew it there. So I know then that if x is -2, y is -7, is a point on that line. So if I put that in the equation, that would be completely appropriate. And that gives me enough information to figure out what b is, all right? So, okay, it shouldn't be too hard to do that. Let's see, -24 plus b. So, okay, b is equal to 17, all right? Hits the y-axis way up at 17 somewhere. So my equation for tangent line T1, this one right here, turns out to be y is equal to 12x plus 17, okay? So there's one of them right there. According to my picture, that's tangent line T1. So what about the other one? Well, if we can find one, we can definitely find the other. So tangent line T2, what do I know about it? Well, it is a line. A tangent line, I hope it doesn't surprise you, is a line. And it has equation, therefore, y equals mx plus b. I know the slope is 12 because that was the whole concept of the problem. And then for line T2, I know that it goes through this point, 2 for x, 9 for y. Okay, so that means it would be appropriate to put 2 for x, 9 for y, and that would be enough information to figure out what b is. Okay, so I'm going to get, continue over here, 9, 24, and then plus b, and then so I'll get b is equal to -15. Okay, all right. So then tangent line T2 is y equals 12x minus 15. It hits the y-axis down there somewhere at -15. That has a slope of 12 though, okay? So let me put my other answer, let me put them together. There were two answers, just like I thought. The geometry of the situation led me to think that there would be two answers. There's the first one, and then the second one. Y is equal to 12x minus 15, okay? Two tangent lines satisfy the setup of the problem. All right, T1, T2. Okay. All right, so two problems down. I got one more that I want to show you. Let's do this one. Okay, but this one's not hard, but I think there's something just by the way that this one's stated, it might be a little confusing. Okay. And that's true, I suppose, when you're learning math and they give you a lot of information and you have to sort through it and figure out what's relevant and how to use it, okay? That's kind of like this one, but this one is really not very hard once you get a handle on the information. So here, a curve is given. Y is equal to f of x. The formula for this curve is unknown. We just know that it's a curve somehow, okay? Here's what we do know, though. The tangent line at the point 2 for x, 3 for y on the curve, so say like this point, passes through the point 4 and 4, not on the curve. So we have a situation something like this, all right? Now, okay, so that's what we got. That's all we have. Question is, can you figure out what f of 2 is? And can you figure out what f prime of 2 is? Okay, how can we use the information that's given to figure those out? All knowing that I don't even have this equation, okay? Okay, so let's, the first one, that's just function notation, f of 2. What does it mean when we say f of 2 is 3? It just means that there's some function and when you put 2 in, you get 3 back out. That's what a function is. Input and output, right? Function notation just allows us to write the input and the output together like that. Is there another way to think about it? Well, okay, if your variables are x and y, then we're just saying that, well, the x goes in and the y comes out, all right? So you could say the point 2 for x, 3 for y was on the curve if you wanted to, and that would be true, but you could also say f of 2 is equal to 3. So you see how easy that one was. It's just function notation. That's what function notation is. When people learn algebra, they're usually like, they're okay with this, 2 for x, 3 for y. I go right 2, I go up 3. But then there's always, or at least for most people when they learn algebra, there's something more confusing about function notation. But it's the same thing, all right? Okay, so if that seems a little weird to you, I'll just say, well, it's really no different. It's the same as there being a point where x is 2 and y is 3. That's it, on the curve. Okay, what about this one, f prime of 2? What's that mean? Well, what is f prime? So f of x is the curve. It gives you the x and y coordinates for the points on the graph. F prime tells you the slope of the curve. So for like this one here, I would say, well, f prime of 2 means the slope of the curve at the point where x is 2. All right? The slope of the curve, though, is the same thing as the slope of the tangent line at the point. So we could figure this out if you tell me what the slope of that line there in red is, because that would be the slope of the curve. All right? Well, that should be easy to do. I've got a line, I got 2 points. That's all I need to figure out the slope. Okay? So the slope of the curve at x is equal to is the same thing as the slope of the tangent line at the point where x is equal to 2. But given that I have 2 points on that line for reference, it's going to be rise over run, isn't it? It goes through points 2 and 3, 4 and 4. 4 minus 3, that's the rise. 4 minus 2, that's the run. The slope is 1/2, okay? So f prime of 2 is 1/2. What that means is the slope of the curve at the point on the curve where x is 2 is 1/2. So part of math is learning to read math, right? Probably none of the math was that difficult here. I had to do some subtracting, some dividing, so on. But I had to know how to read it. I have to know what this says, right? It's notation, it's symbols that you learn to read. On top of that, we've got to put concepts together, all right? So I'd say, like, for the most part, there's exceptions. This topic involves learning some notation, learning some symbols, learning how to read it, okay? So you might go about learning it with that in mind.